Okay. Okay. So hello everyone. Good evening to all. I hope my voice is clear to all. Is my voice and my screen is visible clearly to all? Please let me know in the chat box if everything is good to start the class. Okay. Okay. So hello everyone. Good evening to all. I hope my voice is clear to all. Okay. So let's start the class. So in the last class, I gave one homework question to you, right? Hello admin. Which ZNB is it? So in the last class, I gave you one homework question to you all. So how many of you tried these questions and got the answer? Can you please respond in the chat box? The question is like this: if the coefficient of x square and x cube are both 0 in the expansion of the expression 1 plus ax plus bx square into 1 minus 3x to the power 15, right? In power of x, then you need to find the order pair AB. That means you find basically you need to find the value of A and B, right? So which of the following is correct? So already I have written the given expression in the questions. So how we can solve these questions? So see, here we have a binomial expansion, but with the binomial expansion, other also with one quadratic expression is multiplied with the binomial expansions, right? Okay, so how we can solve? In the previous class also we solved similar type of questions where some coefficient of some terms are given and you need to find some values of A and B or P and Q, right? In the last class we solved one questions. Okay, so similarly here also, if we'll write the expansion of 1 minus 3x to the power 15, so what will happen? Just to see, 1 plus ax plus bx square. If you will write the expansion of 1 minus 3x to the power 15, so how many terms are there? 16 terms are there. So this will be summation r is equal to 0 to 15. Okay, so nc15, sorry, okay, 15 cr, that is 1 to the power 1 minus 3x to the power 15 है ना, so that is minus 1 to the power in my 15 minus 1, you can write it or not, so that is minus 1 into, because why I am writing minus 1, because we have in the expansion we have minus signs, right? So 3x to the power r, is it or not? Yes or no? So this is my expansion. Now we need to find the coefficient of x square and coefficient of x cube. Okay, so how we can find the coefficient of x square and x cube? So just we'll further simplify it. 1 plus ax square whole into summation r is equal to 0 to 15 cr minus 1 into 3 to the power r into x to the power r. We can write na, no issues. Is it or not? Okay, so if this expansion or this expression we are getting, first duty is to find the coefficient of x square and x cube. So how we can find the coefficient of x square and x cube? Let's see. Just take this expression to the next page. Okay, so see, if this is we are having, we need to first find coefficient of x square, right? So coefficient of x square, how we can find? We need to multiply with also this binomial expression, sorry, quadratic expressions also. So see, we need to find the coefficient of x square. That means the power r, the value of r must be r, 2, right? So when we'll multiply 1 with this expansion, when we'll multiply 1 with this expansion, so what will happen? So this will be, this will be 2 na, r must be 2, because we need to find the expansion of x square. That means x square, this would be x square. Here this would be x to the power r, and r is equal to 2 लेना है मुझे, ठीक है? So if we'll multiply 1 with this expansion, this will be 15c2 minus 1 to the power r na, minus 1 to the power r, that is 2, n minus r, okay, r, that is 2. That is 2 means minus 1 become minus 2, 1 to the power 2 becomes plus 1. So 3 square into x to the power 2. Is it or not? है ना? So this, then plus, this is plus. Then we'll multiply ax with this expansion also. So here the to become x square, what are the possibilities? 1 into x square, is it? Then ax into x, then x square into 1, right? So this must be happen. Is it or not? Right? So second term will be, so if we'll multiply plus a into x we have already, then we need to make this r as 1, right? So this will be 15c1 minus 1 to the power 1 is minus 1. So minus 1 into 3 to the power 1 into x, right? Plus similarly ax square. So a or b, it is a or b, sorry, b, huh? This is b. Oh, this will not be, this is b, huh? So b into x square, that means r, here r must be 0. If r must be 0, then this will be 15c0 minus 1 to the 0 is 1, 3 to the power 0 is 1, x to the power 0 is 1, right? So these are the, actually when we will find this, what you are getting, this will be the coefficient of x square, and if you will calculate it, it will give you 0. If you will calculate it, it will be giving you 0, right? You can calculate it and it will be giving you 0. Okay. Similarly, now we need to find, yes, now we need to find the coefficient of x square, x cube, the coefficient of x cube. So what is the expression we have till now? So take this one also. Sorry, got here, we'll paste. Okay, see. So if we have this one, now we need to find the coefficient of x. So try to find the coefficient of x. So what will happen actually? Coefficient of x cube. So what are the possibilities to make coefficient of x cube? One is 1 into x cube. Then other one is a x into x square. And the final one is b x square into x. So these are the possibilities to make r as 3, right? So see, if we'll multiply 1 with this, all these terms, then what will happen? 1 with all these terms. So then it becomes 15c, r must be 3, because when we'll multiply this with 1, so it will be giving you 15c3, because we need to make this expansion when r is equal to 3. So we need to find the coefficient of x cube. That's why we are making r is 3, right? So 15c3 minus 1 to the power 3, 3 to the power 3 into x to the power 3, right? Is it or not? Okay. So now we need to find the coefficients only, na? So we don't need to write x cube here also. and also in the last page also we don't need to write x cube here and x. Okay, just write the coefficient, all the coefficients, right? So see here also we'll write 3 to the power 3 and x to the power 3, it's not required, plus when we will multiply ax with this expansion, so here r to be 2, right? So a into 15c2 minus 1 to the power 2 c to the power 2, right? A into okay, plus b into x square, b into x square. So already we have here x square, so that means in the expansion r must be 1, so this will be 15c1 minus 1 to the power 1 3 to the power 1. Okay, so when we will calculate this also you will be getting 0, right? So when you will be calculating this also you will be getting 0, and after finding both the equations you will be getting a and b, the value of a and b, and the order pair a b as option D is correct. You can check it by calculating the things. Okay, so this is the concept you can use here. Okay, chalo. So I hope this is clear to you all. You need to solve this by your own. I already discussed the procedure or the way how we can solve these questions. Just you need to calculate all this combination by using the formula. Okay, okay. So let's move to the general term. Already we know what is general term. So general term is this: TR is equal to TR plus 1 is equal to NCR a to the power n minus r b to the power r. Already we know this where r is lying between 0 to n. Yes or no? 0 to n. Is it or not? Yes. So now we'll solve one questions from general term. Okay. So if this is the question, here it is asking if the fourth term of the expansion 2 by x plus x to the power log x to the base log x whole to the power log x to the base 8 here it is given. Okay, I'm writing this again: 2 by x plus x to the power log of x to the base 8 whole to the power 6. Okay, and it is given as 20 into 8 to the power 7. Okay, it's given as the fourth term. Okay, so t4 of this expansion is given as 20 into 8 to the power 7. So you need to find the value of x, right? Now you need to find the value of x. So how we can do it? So first, the thing is, already it is given that T4 is or fourth term of this expansion is given. Okay, so what will be the general term of this? So how we can find the fourth term of this expansion? So first we need to know what is the general term of this expansion, right? So what should be T? So TR plus 1, what is the formula to find the general term? TR plus 1, 6CR 2 by x to the power 6 minus r into x to the power log x to the base 8 whole to the power r. So this is my general term of the given expansion. Okay, where r is lying between 0 to 6. Yes or no? Okay, now if we'll simplify it, what will happen? So 6CR 2 upon 6 to the power r, 2 upon x to the power 6 to the power 6 minus r. So we are writing the constant terms first. 2 to the power 6 minus r. If we'll take this x to the power 6 minus r to this term, so this becomes x to the power log of x to the base 8 whole to the power r upon x to the power 6 minus r. Is there any problem? We can write it or not? Yes, we can write. Yes. Okay. So now x to the power 6 minus r. So this is actually it is given as x to the power log x to the base 8 whole to the power r upon x to the power 6 minus r. Yeah. Okay. So this is the simplest form we are getting till now. Now, if it is the general form, if it is the general form, sorry, general term of this given expansion, then then so what should we do? It is already we have, right? So if I'll ask you to find T4, that means the R value, the value of R will be 3 plus 1, that R value of R is 3, is it or not? So this becomes 6C3 2 to the power 6 minus 3 into this will be x to the power it is given that 2 upon x to the power 6 minus 1. Okay, so this will be 2 to the power 6 minus 3, and this is x to the power log of x to the base 8 upon whole to the power, this will be 3 and x to the power 3, right? So we can write this as also directly, right? We can whole to the power x to the power 3. We can write this or not, is it or not? So further simplifying it, we are getting 6C3 into 2 to the power 3, 2 to the power 3 into 1 upon x cube into x to the power log of x to the base 8 whole to the power 3. So by using the properties of logarithmic, right? By using the properties of logarithmic, we know we can write this as this can be written as also x to the power log of x to the base 8 whole to the power 3. This can be written as also 3 into x to the power log of, sorry, x to the power 3 into log of x to the base 8. Acha, we can write this as x to the power 3 log of x to the power 2 to the power 3. Yes or no? So this can be written as 3 upon 3 when the power of base of logarithmic is 3, and here also we are having 3. So it will be 1 upon 3 into log of x to the base 2. So 3 will be cancelled out. So this will be log of x to the base 2. So by using the logarithmic properties. Okay. So now if we'll solve this one, so what we are having 6C3 into 2 to the power 3, 6C3 into 2 to the power 3, we are having into 1 by x to the power 3 into 1 by x to the power 3 into finally what we are getting, this is log of x2, this becomes log of x to the base 2, right? Log of x to the base 2 we are getting, is it or not? Log of x to the base 2, and x to the base 2, is there anything we are having, guys? Log of 3 into, sure, 3 into log of x to the base 8. Sure, so that is x to the power log of x to the base 2. Achha, already we are having na here. So this is actually, oh, I did some mistake here. Sorry, actually. So this is, we need to take this one only. Okay, the power, what we are having in power. So log of x to the base 8 to the power 3. This will be, if you are taking this, then here you will be having x to the power log of x to the base 2, right? Log of x to the base 2 we are having. Okay, so similarly here we are having x to the power log of x to the base 2, right? X to the power log anything we left with anything. R3, 3, 3, 3. Is there anything we have left? No. Okay. Chalo, ठीक है. So let's calculate. 6C3 2 to the power 3 into, here we are having x cube and here we are having x to the power log of x to the base 2. So this becomes log of x to the power log of x to the base 2 minus 3, right? Yeah, minus 3 we are having. And this is my T4, right? So T4 is given as, it is already given as 20 into 8 to the power 7, right? 20 into 8 to the power 7. Acha. So if you'll calculate na, guys, if you'll calculate, so this quantity will be equal to this quantity. Okay, sorry. This 6C3 into 2 to the power 3 will be 20 actually. Okay, so if this and this will be cancelled out, what we are having finally? We are having x to the power log of x to the base 2 minus 3 is equal to 8 to the power 7, right? So 8 to the power 7. And also here we are having 2 to the power 3, right? 2 to the power 3 is 8. So 2 to the power 3 is 8. If we'll cancel out this with this, we are having 8 to the power 6. So finally we are having x to the power log of x to the base 2 minus 3 is equal to 8 to the power 6. Okay. Chalo, ठीक है. So these things we are having right now. Okay. So how we can solve it? If we'll take log on both sides. Suppose we are taking log on both sides, it will be log of x minus 3 to the base, sorry. Log of x to the base 2 minus 3 into log of x is equal to 6 into log of 8. Is it or not? 6 into log of 8. Okay. Further we can simplify it also. If we can write this as 8 to the power 6 को हम ऐसे भी लिख सकते हैं ना, that is 2 to the power 3 whole to the power 6, right? Because base is 2, will make it 2 to the power 18, right? So this will be, if we'll take 2 to the power 18, this will be 18 into log of 2 to the base 2, right? We are taking the base as 2 on both sides, right? So if this happens, then 18 into log of 2 to the base 2 is, so this is 1, log of 2 to the base 2 becomes 1 or not? Yes. So 18 is equal to, we are having log of x to the base 2 minus 3 into log of x, right? So if you'll take, let take log of x is equal to t. Now try it. If we'll take log of x is equal to t, so what will happen? See, if we'll take log of x is equal to t here, so this becomes 18 minus t minus 3 into t. So this becomes 18 is equal to t square minus 3t. So this is t square minus 3t minus 18 is equal to 0. So finally we are getting one quadratic equation. So if we'll solve it, this will be t square minus 6t plus 3t minus 18 is equal to 0. So solve it. So this will be, if we'll take common t, so this will be t minus 6, and here we will take common 3, this is 3 minus 6 is equal to 0. So we are getting t minus 6 into t plus 3 is equal to 0. So we are getting t is equal to 6 and t is equal to minus 3. Okay. So t is equal to 6 and t is equal to minus 3 we are getting. So what we have taken, if we'll resubstitute the value of t here, that is log of x to the base 2 is equal to 6 and log of x to the base 2 is equal to minus 3. So by we know na, if a raised to b is equal to c, then log of c to the base a is equal to b. Already we know this formula from logarithmic. So if we'll apply this one, so 2 to the power 6 will be x here and 2 to the power minus 3 will be x here. So 2 to the power 6 is 2 to the power 6 and 2 to the power minus 3 na? Yeah. Oh, so this is the answer actually, 2 to the power 6 and okay. So this will be 2 to the power 6 is actually 64, right? Yes, 64. Yes. So x is equal what is it? What it is given in the question? Or it's a numerical questions. Okay. So 2 to the power 6 is 2 to the power 3 to the power 2, that is 64, and 2 to the x is equal to 2 to the power minus 3, 1 upon 8. So these are the answer. X is equal to either 64 or 1 upon 8. Okay. So which one you can write? If it is an integer type question, you must write 64, or if the option is given one of these two, then you can write one of the answers. Okay. Okay, so I hope this is clear to all of you. It's very actually it is a lengthy questions. It came in the previous question 2012. So 2022 mains question actually it is. The concept is simple, but you need to do a lot of calculations, right? So here you have to use the properties of logarithmic here. So you need to think about the solutions more, right? Concept is simple, just expand the things. So after expanding the binomial expansion, so what should you do? How to calculate? This is important, right? So you can ask, sir, how we can know, we'll know how to solve all these things. So actually the thing is, the main thing, I will suggest you, if you'll solve a lot of questions, right? If you'll solve varieties of questions, then automatically the mathematical skill will be developed and you can solve the questions. Automatically your pen will going towards the solution, right? Okay. So this is the answer. I hope this is clear to all of you. If you have any doubt, you can ask. See, I think you have some questions in here only. Huh? So see here, actually what we did here, x to the power, we simplify this term, x to the power log of x to the base 8 to the power 3, right? So x to the power log of x to the base 8 to the power 3, right? So instead of taking this, we can take only the power. If we'll take the power only, so what will happen? So log of x to the base 8 to the power 3, it can be written as 3 into log of x to the base 8, and this can be written as log of x to the power 2 to the power 3. Okay, so when 3 is multiplied here, if you have 1, then it, if you only you have log of x to the base 2 to the power 3, then you can write this as log of 1 upon 3 into log of x to the base 2. So similarly here, the base is 3 and it is multiplied with 3, so 3 by 3 log of x to the base 2, right? So this becomes x to the power log of x to the base 2, right? So this is actually happened here. I did the calculation here. Okay, so then the very simple calculations are there. 6c3 is 20 and 20 will be cancelled out, and 2 to the power 3, here we have 8 to the power 7, so 2 to the power 3 will be cancelled, 8 to the power 7, and we will be having 8 to the power 6, right? Then log x is equal to t you can take and you will get the answer. Clear beta? Sure. If it is clear to all, go to the next thing. Now, how we can find the middle term in the expansion? This is the most important thing in the chapter. So actually in the binomial theorem in JEE mains examinations, questions are coming from you need to find the coefficient of some term in the expansion, and also you will be asked to find the greatest term, or you can find you have to find the suppose 15th term of this. If you are given the expansion and you are asked to find the 15th term of this expansion, and mains questions actually. If here also, if you have a if you are given a expansion and you are asked to find the middle term of the expansions, okay. So how we can find, if you have a expansion, binomial expansion, how we can find the middle term of a binomial expansion? Okay, so let's see. We are considering the same expansion. Suppose I am taking here a plus b to the power n. What is the expansion of this? We know. What is the expansion? That is summation r is equal to 0 to n. Okay, ncr a to the power n minus r and b to the power r. So this is my expansion. Okay, suppose in this expansion, okay, so as like if you take very simple example, suppose I'm taking case 1. There are two cases, hai? Two cases. Suppose n is even. I'm taking the first case, that is when the n is even, right? If n is even, so how we can find the middle term of a expansion? Suppose we are taking a plus b to the power 4, the expansion of a plus b to the power 4. So how many total number of terms you have here? In this expansion we are having 5 terms, right? So in total we are having here 5 terms. Suppose those terms are t1 plus t2 plus t3 plus t4 plus t5, right? So what is the middle term here? So first case we have taken n is even, right? If n is even, so what is the middle term here? Anyone can say what is the middle term here? Okay, so what is the middle term here? We are having the middle term as t3, because in the right of t3 we are having 2 terms, t4 t5, and to the left of t3 also we are having 2 terms, that is those are t1 and t2, right? So t2 is my middle term here. Okay, so t2 is my middle term here. So single, when n is even, so we are getting single middle terms. Okay, so when we are having n as even, so we are getting single middle term. Okay, that is how we can represent this middle term t3, or how we can find. So we can write this as, this is the third term, right? This is the third term, and this is actually 3. Third term means t3. Okay, so we can write this as 3 plus 1 upon 2. Is it correct? 3 plus 1 upon 2. Is it correct? That is 4 upon 2. No, this is the third term. So how we can represent it? Tell me. You can write this as 4 by 2 plus 1. Yes or no? 4 by 2 plus 1. That is n is 4 here given. So n by 2 plus 1. That is 4 by 2 plus 1 term is my middle term, right? So the simple thing is, what we are going to conclude here, remember, middle term, when n is even, middle term is equal to n by 2 plus 1th term. Okay, n by 2 plus 1th term. So this is my formula to find the middle term when n is even. Is that clear to everyone? If n is even, middle term will be n by 2 plus 1th term. Is that clear to all, guys? Okay. Chalo. So if we simplify it, okay, we are getting the middle term as here, middle term we got, that is n by 2 plus 1 term, right? So that is, we can write this as t n by 2 plus 1 is equal to, so R is n by 2. Yes or no? R is n by 2. So we can write this as NC, the general term. What is the general term will be? The term will be, what is the term? Sorry, if the n plus n by 2 plus 1th term is your middle term. So how can you find the term? The term will be where R is n by 2. So NC n by 2, NC n by 2, a to the power n minus n by 2, b to the power n by 2. Or we can write this as NC n by 2, a to the power n minus n by 2 is n by 2, b to the power n by 2. Right? So what is the middle term here you are getting? This is your middle term, that is NC n by 2, a to the power n by 2, b to the power n by 2. So if in the question it is asked, what is the binomial coefficient of middle term? What is the binomial coefficient of middle term? So this will be the binomial coefficient of middle term. Remember, this one is important also, right? Okay. So this is all about when n is even. Okay. So now we'll discuss if n is odd. In the expansion a plus b to the power n, if n is odd, how we can find the middle term, right? So suppose we are taking now, let n is equal to 5, right? So a plus b to the power 5. So total number of terms is 6. 6 numbers of terms we are having. Suppose those terms are t1 plus t2 plus t3 plus t4 plus t5 plus t6, right? So when n is odd, total number of terms we are getting 6, right? So how many middle terms you are? So can you tell me what is the middle term here? What is the middle term here you are getting? We are getting 2 middle terms. We can say we are getting 2 middle terms. Those are, one is T4 and another one is T3. Okay. So we are getting here 2 middle terms, right? 2 middle terms we are getting in case of when n is odd, we are getting 2 middle terms. Remember, when n is odd, we are getting 2 middle terms because T3 plus T4 to the right of T3 plus T4, we are having two terms, that those are T5 and T6, and also to the left we are having T1 plus T2. So that's why we are saying we are having 2 middle terms when n is odd, right? So similarly, as what we did in case of even odd terms also, odd number of n. So when n is odd, है ना? So here also we need to find the derive the formula to find the middle term also. So how can you represent? How can you represent T3 and T4? That is important, right? So here the n is given as 5, right? So by using n, how can you find 3 and 4? That is important, right? So we can write 1 is 5 plus 1 by 2th term and 5 plus 1 by 2 plus 1th term. See, 5 plus 1 by 2 is 3, that is T3, and 3rd term, and 5 plus 1 by 2 plus 1, that is 4th term. Is it clear to all of you or not? So these are my middle terms. So how can you represent it? We can represent it as also, n plus 1 by 2th term and n plus 1 by 2 plus 1th term are my middle terms. When n is odd. Clear, guys? Okay. Now, how can you find the terms after finding the middle terms? Okay. So how can you find that those terms? So you got only you got to know that third term and fourth terms are the middle terms of this given expansion. If I'll ask you what is that third term and what is that fourth term, so how can you find? That is also important. Yes or no? So see here. That is here we got. Okay. We got n plus 1 by 2 eighth term and n plus 1 by 2 plus 1 terms are my middle terms, guys. Okay. So if I'll ask you to find Tn plus 1 by 2 eighth term. So guys, we know since n plus 1 by 2 is equal to r plus 1. Yes or no? So general term, that is T r plus 1. Na? So r plus 1 is equal to n plus 1 by 2. So r becomes n minus 1 by 2 or not? R becomes n minus 1 by 2 or not? So if r becomes n minus 1 by 2, so this becomes T n minus 1 by 2 plus 1. Yes or no? T n minus 1 by 2 plus 1. So now we can easily find the middle term. So that is NC n minus 1 by 2. Okay, na? NCR into a to the power n minus r minus 1, n minus r, that is n minus 1 by 2, n minus r, b to the power n minus 1 by 2. So if we'll simplify it, we'll get NC n minus 1 by 2. First case, this is the case 1. Case 1, that means for this term, for this, we are solving it. So NC n minus 1 by 2, a to the power n minus, that is 2n minus n. 2n minus n is n, and 2n minus n plus 1. So n plus 1 by 2, n plus 1 by 2, b to the power n minus 1 by 2. So this is my middle term when this is when. Okay, this is my middle term. If you will consider this one. So last one, if you will consider this one, if you will consider this one, so what will be the middle term? So this is the way how we can find. Okay, how we can find this term n plus 1 by 2 plus 1 term. You don't need to remember all this formula. Just we are discussing the method. In generally, just we are discussing the method, right? So see, if we'll consider this one, that is T n plus 1 by 2 plus 1th term, right? So here r is n plus 1 by 2. Okay, so it is very simple to find the term, that is NC n plus 1 by 2 a to the power n minus n plus 1 by 2 into b to the power n plus 1 by 2, right? If we'll simplify it, NC n plus 1 by 2 a to the power 2n minus 1, 2n minus 1 is n minus 1 by 2 b to the power n plus 1 by 2. So this is my second middle term of when n is odd. So this is the way we can find all the middle terms. Now if we'll solve the questions, you can understand how we can find the middle terms. Remember, these are the things. This is when n is even, so n by 2 plus 1th term is your middle term, and when n is odd, this is first one is n plus 1 by 2th term, and second is n plus 1 by 2 plus 1th term. Okay, so already we have discussed these things. So let's solve one questions, then we can understand. Okay, so before going through so many theories are there also, let's discuss these things also. Okay, okay, so if you are given a binomial expansion, okay, so and you are asking to find the when the binomial coefficient will be maximum. so what is the maximum binomial coefficient of the given expansion? How can you find? So when n is equal to 2, suppose I am taking n is equal to 2, you can see the figure here. You can see the figure here. This skyline represents to n is equal to 2. Suppose I am taking a plus b to the power 2. I should not use the red color because it will be difficult to visualize to you. So that's why I'm erasing these things. Okay. I'm using yellow color. Okay. So when n is equal to 2, suppose I'm taking a plus b to the power 2. That is, the binomial coefficients are, actually the binomial coefficients are, you can see na, a square plus 2ab plus b square, right? So the binomial coefficients are nc0 a square plus, instead of 2 we can write 2c1ab plus 2c2b square. So these are my binomial coefficient. One is nc0, second one is 2c1, sorry, 2c0, 2c1 and 2c2. So see here, for the skyline, you can see here 2c0, 2c1 and 2c2, right? 2c2. So what is the maximum, value of binomial coefficient? That is 2c1, right? That is 2c1. Is that clear to all? Yes or no? If n is even, that is, see here, if n is even, okay, then r is equal to n by 2. R is equal to n by 2, that is 2 by 2. See here, 2c1. That is the maximum. R value will be, so n value will be fixed. It is given. Suppose we'll discuss again further. Suppose we are taking n is equal to 3. Okay, so n is equal to 3. If we'll take, see here, if we'll take, if we'll take n is equal to 3, so this will be a plus b whole cube, that is 3c0 a cube plus 3c1, okay, 3c1 a square b plus 3c2 3ab square plus 3c3 b cube, right? 3c1, 3c2. So value of 3c1 is equal to 3c2. Is that clear or not? Yes or no? So what are the maximum binomial coefficient in this given expansion? When n is odd, that is n minus 1, r becomes, see here, r becomes here, r becomes n minus 1 by 2, okay, n minus 1 by 2, that is 3 minus 1 by 2, and n plus 1 by 2, that is 3 plus 1 by 2. So r becomes here is equal to 3 minus 1 by 2, that is 2 by 2 is 1, and 3 plus 1 by 2, 4 by 2, that is 2. So r becomes 1 by 1 and 2. So the binomial, the maximum value of the binomial coefficients in the expansion a plus b to the power 3 will be 3c1 and 3c2. You can observe from the graph also. 3c1 and 3c2 are the maximum, are giving the maximum value in the expansion a plus b to the power 3. Similarly, you can consider for a plus b to the power 4 when n is equal to 4 also. You can see when n is even, so r by 2, r becomes n by 2, that is 4 by 2, that is 2, 4c2 is the maximum value, maximum binomial coefficient. So this is the way to find the maximum binomial coefficient in the given expansion. Is that clear to everyone, guys? Okay, if it is clear, let's move to one question. Let's solve one question. Now, the ratio of the coefficient of the middle term in the expansion of 1 plus x to the power 20 and the sum of the coefficient of two middle terms in the expansion of 1 plus x to the power 19. Okay, So you need to find the ratio of the coefficient of middle term. So first, our job is to solve this question. How we can solve it? The solution is, this is the way. So first expansion is given as 1 plus x to the power 20. Okay, so here n is given as even. Okay, so n is even. So what is the middle term of this expansion? Anyone can say what is the middle term of this expansion? So middle term of this expansion will be n by 2 plus 1th term, that is 20 by 2 plus 1, that is 11 term. Okay, 11 term will be the middle term of the given expansion. Okay, so how we can find the 11th term? So when we need to find the 11th term of the expansion, then r must be, r क्या होना चाहिए भाई, 10 plus 1. Okay, so to find T11, r must be 10. So if r is 10, guys, if r is 10, can you find the term? Okay, can you find the middle term? Guys, can you find the middle term? Always remember, yes, tell me. Here n is given as even, na? Anyone can say? Always remember what you observed here, guys. What you observed here. Remember, always the middle term, the coefficient of middle term is the maximum binomial coefficient. Okay, the coefficients of middle term gives you the maximum value always in the given expansion. In all, between all the binomial coefficient, the binomial coefficient of the middle term will be giving you always the maximum value, right? So here also you can use that one also, and also in the formal way also we can find. So r is 10, just find r is 10, then the expansion, the term will be 20c 10, 20c10, 1 to the power 20 minus 1 into x to the power r, that is 10. Okay, so here the binomial coefficient. So this is the middle term, huh? This one is my middle term. Okay, so this one is my middle term. Yes or no? Okay, so this is also, we can say here, this is also the highest binomial coefficients, because always the coefficient or the binomial coefficient of the middle term of a expansion gives you the maximum value, right? Gives you the maximum value, or you can say this is my highest binomial coefficient of the expansion 1 plus x to the power 10, or another directly we can find also, here also we can say that is, see, that is directly we can say, you can note here, highest binomial coefficient is NC n by 2 when n is even. That is NC n by 2, that is 20C n by 2 is 20 by 2 is equal to 20C10. So this is the binomial coefficient. This is the highest binomial coefficients. Remember, you can note it. Already we have discussed in the previous slide also. You can remember this one. When you are asked, when n is given as even, okay, if you are asking to find the highest binomial coefficients, easily you should remember the highest binomial coefficient will be NC n by 2. Okay, NC n by 2. Clear? So this is my middle term of the first given expansions. Now we'll move to the next. That is, what is the expansion it is given? 1 plus x to the power 19. Okay, 1 plus x to the power 19. Right? So here total number of terms is 20. So n is odd. N is odd. It is given. So two middle terms we are having here. That one is t n plus 1 by 2, 2th term, and t n plus 1 by 2 plus 1 term. Right? So find first n plus 1 by 2, that is 19 plus 1 by 2, 20 by 2 to t10 and t11. So these are my t10 and t11s are the middle term of the expansion 1 plus x to the power 19. So how we can find t10 and t11? So let's find t10 first. So t10, so r must be 1, t9 plus 1, that is 19c9 x to the power 9. Okay, this is t10, and t11, that is t10 plus 1, which one is 19c10 into x to the power 10. So these are my two middle terms of the expansion 1 plus x to the power 19. Okay, now in the question it is asking to find the ratio, of the coefficient of middle term. So so first the coefficient. Okay, now see the ratio of first expansion. Okay, so instead of first expansion of 1 plus x to the power 20, ratio of middle terms, terms of 1 plus x to the power 20 and sum of the coefficients of the expansion 1 plus x to the power 19. So these are, what is the sum of, for this we got 20c. What is the coefficient we got? The first one, that is 20c10, right? 20c10, and for these two sum will be 19c9 plus 19c10. So now can you tell me when you are having NCR plus NCR minus 1, one formula is there. NCR plus NCR minus 1, it will be n plus 1 CR, right? N plus 1 CR. So this will be 19 plus 1 CR, that is CR is 10. So this will be 20 C10. Okay, so sum of the coefficients of middle terms, of the expansion 1 plus x to the power 19 is 20 C10, and also the coefficient of middle term of the first expansion, that is 1 plus x to the power 20 is 20 C10. So the ratio will be, then hence the ratio is 20c10 upon 20c10, that is 1. So answer is 1. Clear, beta? Answer is 1. I hope this is clear to all of you guys. The answer is here 1. Clear? It's a numerical questions, came in 2022 JEE mains. If you understand the concepts very well, then you can solve all the questions very easily, right? Just after this class, you should go through all the notes what you have made, or you can go through any standard book also. There you will get all the details with a lot of huge number of questions also. You go through all the questions, try to solve it. If it is not solved by you, then you can ask, you can take help of your teacher. Then also you can post your doubt in the WhatsApp group by your teacher also, right? Then in the next class I will solve that. Okay. See, so this is the questions. I hope it is clear to all of you. Now let's move to independent of terms. This is very simple, guys. Actually, independent of terms is, so independent of terms is the term which is free of variable. Free of variable. Like if we'll solve one questions, then you can understand. Suppose we are taking simple thing a plus b whole square. Okay. Chalo, ठीक है. We are taking x plus y whole square. Okay. So this will be nc0 x square. Sorry. 2c0 x square plus 2c1 xy plus 2c2 y square. So the term free from variable is called independent. So these are the terms. So this is the term which is free from variable x square. Okay. So if it is big, it is not there. If there is no x square, there is no xy, there is no y square, there is no variable. Okay. We can say the term which is free from variable is called independent term. Okay. Yeah. Okay. Chalo. You can solve one questions also. You can take a screenshot of these questions as your homework questions. Okay. Here it is asked to find the term independent of x in the expansion. This. Okay. If the question is not visible, I'm writing these questions again. X plus 1 by x to the power 2 by 3 minus x to the power 1 by 3 plus 1 minus x minus 1 by, it's a very interesting question also. Okay. X to the power 1 by 2 whole to the power 10. Okay. You need to find the term independent of x. Okay. So you need to find the term independent of x. Take it this question as your homework questions. Okay. So this is time to end your class here. In the next class, we'll solve more questions and also we'll see how to find the greatest term of a binomial expansion also, and we'll see application of binomial theorem in the next class. Means tomorrow we'll be discussing application of binomial theorems and also how to find the greatest term of a binomial theorem. We know how to find the middle term, we know how to find the highest binomial coefficient, we know how to find the coefficient of a term in the expansions. We have studied also independent terms, independent of terms, and we'll solve these questions tomorrow also. Okay. Thank you all. Bye bye. It's time to end your class now. You can go now. Thank you all. Bye bye. Take care, everyone.